Hello students, so today we are solving ISS paper 3 2025 solution. So here we are at question number B. We have to define the general form of the simultaneous equation model. What is that? Simultaneous equation model consists of multiple structural equations of where some variables appear as dependent in one equation and independent in another. So what are a simultaneous equation model which consists of multiple structural equations where same variables appear as dependent in one and independent in other. These are simultaneous. Now the equation looks like, if we write it down, it's let there be m endogenous variable, okay, and k exogenous variable, correct? So here yi is equals to summation j not equals to ij yj plus summation of k1 to k beta ik xk plus mu I, error term we need. So here what is my yi? That is the endogenous variable. What is the xi? That is the exogenous variable. And xk, here xk. And what is the ui? The structural disturbance term. So each equation has endogenous regressor leading to endogeneity. Now comes our next question. Based on the likelihood function, we have to explain the problem of identification. What is that? So here identification refers to the ability to uniquely estimate the structural parameters from the reduced form. So identification means to ability to uniquely estimate the structural parameters from the reduced form. Why? Due to simultaneity, structural parameters are not directly observable. And we may face indeterminacy in estimating them from observed data. Okay. So if we cannot distinguish between alternative parameters, sets that yield the same reduced form outcome. So the equation is not identified. Then it is not identified. Here the question was based on the likelihood function. Explain the problem of identification. Now, what is the role of the likelihood function? Here it comes. Role of the likelihood function. So in maximum likelihood estimation, the likelihood function depends on the joint distribution of the endogenous variables. Okay. And if the parameters cannot be uniquely determined from this likelihood function due to under specification or multi-collinearity, then identification it fails. Okay. Next, what are the type of identification? So it's just identified, under identified, over identified. Okay. So here it's just identified when the number of restrictions imposed is equals to number of parameters to be estimated and unique solution exists and estimable using methods like 2SLS. This is one. When it's under identified, there are not enough restrictions for the same and multiple structural forms explain the same reduced form and it cannot estimate parameters. Cannot estimate parameters. And when it's over identified, more restrictions than needed. It can be estimated and also provides a test of validity of the restriction. So estimation method are 2SLS, 3SLS. Okay. Now finally also give the order condition of identification. What is that? So necessary condition but not sufficient for identification of an equation. Equation of an equation. So let here mk if I take, so here it's m, so it's number of endogenous variables in the system first. Next k, the total number of exogenous variables in the system. This the number of exogenous variable only, but they are excluded. Where? From the particular equation. And what is E? That is number of endogenous variable excluded from the particular equation. Okay. So an equation is identifiable if k plus e is m minus 1. So if m minus 1, then it's just identified. If it's greater than m minus 1, then it's over identified. And if it's less than m minus 1, then it's under identified. Okay. So here, this way we can give the answer for this.